A busy day? Yeah, me too. I'm tired. All right, so we're looking at clusters 1 through 3 review. So basically it just gives you guys an idea of where you are. It just helps you to assess how much you've progressed and if there are any other topics that you need to go back and review. Why are they not showing up? So we're going to go through those questions today. All right. All right, so for clusters 1 through 3, these are all of the topics that you should have some idea of how to do at this point. Because you're midway through the book, you don't have to go with the notion that you should have mastered these by now, but you should be moving towards mastery. So if you're not in a space to where like your scores are increasing when you're testing yourself, or you're still kind of feeling unsure about certain topics, this is your trigger to go backwards. I never want you to keep moving forward through the book and you're not grasping the content. Now, if it's certain smaller topics, it's fine. But if it's like entire sections like these, then you definitely need to take the time to go back. So the questions we're going over today for clusters 1 through 3, we're going to be looking at estimation and rounding. We're doing converting fractions, decimals, and percents. Compare and order rational numbers. So conversions within and between systems. We're doing ratios, word problems, proportion word problems, percentage word problems, the relationship between two variables, statistics, and tables, charts, and graphs, and geometry. And again, this is just a midway point through the book, just to kind of give you guys an idea of where you are content-wise. And it's just another example of assessing yourself. All right, and then this just breaks down specifically based on those topics, what you should know how to do at this point in the book. All right. All right, so let's go ahead and get started. All right, so we're just going to go through all the questions just so we can kind of see where everybody is. So you're able to assess where you kind of making your mistakes and all that stuff like that. All right, so for number 1, it says, which unit is best when estimating the length of a coffee table? So this particular question, this is an example of estimating and rounding. So you also want to make sure you kind of know where the topics are coming from, so you know where to go back and review. And at the end of this, there's a checklist that shows you which questions go with which topics, so that helps to redirect you as well. All right, so which unit is best when estimating the length of a coffee table? So when they give you questions like this, it's going to be everyday objects. Make sure you guys are utilizing that cheat sheet that kind of gives you an idea of like the length and width and weight of everyday things so you can compare. So here, they give us 4 options. They give us feet, inches, ounces, and liters. So first things first, you want to figure out what they're asking you. So they're asking us for length. So I always tell people to kind of work backwards from these because you want to eliminate what doesn't fit. Well, I know that ounces is for weight, so that doesn't fit. Or mass. Liters, that's volume. That doesn't work. So now we're looking at feet and inches. So both of these can be used to measure the length. We want to know what's the best unit in this particular case. So if you think of a coffee table is like a decent size. With these types of questions, it just comes more so down to the size of the unit matching what we're doing. So inches, because inches are so small, inches will be used for something that's more precise versus something that's the size of a coffee table. So in this particular arena, feet would be the better answer. That doesn't mean that inches isn't a possible answer, but you always want to know that we're looking for the best answer. That makes sense to everybody? All right. So the computer cluster, some more precise. All right, for number 2, it says estimate the square root of 8. So for these types of questions, make note that this is something that you can just use the calculator for, because the square root button is on the calculator. Okay, and I'm just writing these notes just so you guys can have them for when you go back and review the video, so you will know. Some of these questions, you always just use your calculator. So they give you guys a 4-function calculator. Can you guys see my calculator on my screen? No? I don't know how I'll be able to show it. Let me see. Okay. Can you see calculator now?
Yes.
Okay, so this is considered, well, this isn't really it's kind of a 4-function, but not really. So yours will look like this, minus this fraction and the square, but you guys will have this square root button here. So with that type of calculator, you always insert the value first. So see how we're saying the square root of 8, and then you would hit the square root button. And that's exactly how you would do it on your test. Okay. And then we know from here, we're just gonna write out the first couple numbers, 2.828. All right, so that was roughly 2.828. All right, and then we want to go ahead and round. So we know it's not 2.9. No, it's not 2.5. All right, so we're left with 2.82 and 2.83. So if we look at the 10th place, I have a 2 there. There's an 8 next to it, which means that the 2 will increase to a 3, which is be 2.83. So again, this is still the estimating and rounded. So if you're having an issue with that, then you go back to that section in the book to review. Does anybody have a question about that?
Yeah, I just failed the round, but.
So with this one, I will say, because I think this is probably like an earlier version, when I updated it, I did specify to round to the nearest 100, because I know how that can, because I didn't specify, it made it a little bit harder to decide.
Yeah, because it's not specified here, but for the test, we would round, correct?
Yeah, you would round, because if you do get a question like this, it wouldn't be like a perfect square, but they'll specify, they'll say round to the nearest whatever 10th or 100th. Or, yeah, okay. So you'll be good to go. All right, number 3 says estimate the length of a twin size mattress. All right, so here we always want to check the units first, because we're looking for length. So we have centimeters, we have inches, we have feet, and we have meters. So all of these measure length. So now we need to look specifically at the values of the numbers associated with those to see what fits and what doesn't fit. So we also want to still do a process of elimination. So if we go through, we're looking at a twin size mattress. So we're all familiar with mattresses and about what size they are. And so if we look at 75 centimeters, centimeters is very small. So in this instance, centimeters wouldn't work because it just wouldn't be long enough. And just to give you guys an example, one ruler is how many? It's like 20 something. I think so. 30. Yeah. Okay. So one ruler, which is 1 foot, is 30 centimeters. So if we think in the context of this particular question, if we were given 75 centimeters, that's about 2.5 rulers. And we know that if we laid two rulers like on top of each other and a half of one, it wouldn't be long enough to fit a twin size mattress. So this is when I say you guys have to kind of have an idea of everyday objects and how to compare them. This isn't like a really big topic that you would stress yourself out about. Just be familiar with it, but don't try to, overdo it with this one. All right, we have 75 inches, so that's something that we could use, but we want to eliminate the ones that don't fit first. All right, we have 75 feet. Well, I know that one ruler is 1 foot. So if I have 75 of those, clearly that's going to be way too long. All right, and then we have 75 meters. So if you guys think of like a meter stick is longer than the actual ruler. So that's way too long. So that will leave us with 75 inches. Do you guys understand like the logic that I'm using? So with these types of questions, you always want to kind of eliminate the ones that don't fit first, and then you justify whatever's left over.
Makes sense to me.
All right. All right, number 4. So now we're moving into converting fractions, decimals, and percents. So it says convert 6/29 to a decimal. So anytime we're converting from a fraction to a decimal, you just divide the top value by the bottom value. That's all you do. 6 divided by 29, and that gives us something. Let's see. 0.2068. All right, so based on our answers, we know we can eliminate C and we could eliminate A. All right, so again, if you have an older version of the book, I didn't specify here, but you always want to round. So here we would have rounded to the nearest 1,000. So 6 is in the thousandth place. So because we have an 8 here, that would increase to a 7. And again, for your test, they'll specify. Oh, excuse me. They'll specify for you guys. All right, number 5 says convert 125% to a decimal. So anytime we go from a percent to a decimal, you always move your decimal 2 places to the left. So in this instance, anytime you have a whole number and you don't actually see the decimal, then you always can assume that it's at the end. All right, and then from there, we go 2 places to the left and leave our decimal. So it's 1.25. Which will be B. And you guys kind of see how I'm moving through the problems. You want to create this type of flow. You want to do the question so much that as soon as you see it, you know exactly what to do. And you're not second guessing yourself. All right, number 6 says convert 0.85 to a fraction in simplest form. So anytime we convert from a decimal to a fraction, there's 2 different strategies you can use. You can actually say the value out loud. That lets you know how to set it up. Or you can go by the number of values after the decimal, and that'll tell you how many zeros are in the denominator. So if we read it out, it says 8500. So that just lets me know that I'm doing 85 over 100. But also, another trick too is that because there are 2 values after the decimal, that lets me know that I should have 2 zeros in my denominator, and the 1 will always be the leading value. So it just depends on you and what you decide to do. So because it says in simplest form means that you have to simplify or reduce. All right, and then we can reduce 85 over 100 by 5. And that gives us 17 over 20, which would be A. All right, so sub skill there. make sure you know how to reduce, because you have to reduce for this test. Everybody good so far?
Yep.
Yep. Okay. All right, number 7 says identify the smallest value. So we have -12, -13, -14, and -10. So negative numbers, you want to make sure you understand that concept with the idea that the further away from 0 that a value goes, so the further to the left it goes from 0, the smaller it gets. So we have -12, -13, -14, -10. So if we drew a number line, and we had 0, right? And let's just say we had -10, and then we had -15. All right, well, I know -10 is here. I know that we would have -12, and then it would be -13, and then -14. Uh-oh. Let me redo this so I can see. All right, so we have -10 here. We would say this would be -12. Then we would say -13, and then -14. So based on this, which value will be further away from 0? And in this case, it would be the -14. So the further away it goes from 0 to the left, the smaller the value gets, okay? So if it was the opposite way, they want to know what the largest value was. -10 would be the larger value because it's the closest one to 0 on the number line. All right, number 8 says, arrange the values in descending order. We have 42%, the square root of 36, 3/8, and 0.376. So anytime you guys are comparing rational numbers, that's what these are considered. You always want to compare them in the same space. My go-to is to change everything to decimals, but you also have the option to change everything to percentages so that it's easier to compare. All right, so this is when our sub-skill, our conversion sub-skills come in. So I know to go from a percent to a decimal, I go 2 places to the left. So that's gonna give me 0.42. I know the square root of 36, I can put that in my, 0.36, I can put that in my calculator. That's gonna give me 0.6. We wanna change 3/8 to a decimal. We do the top value divided by the bottom value, and I think that gives us 0.375. And then we have 0.376. All right, so the question is asking for descending. So descending means greatest to least. All right, so our biggest value here, whenever you're comparing decimals, you always look at the first value after the decimal, kind of determine what we're doing. Oh, well, no, I can use the other trick I use. So I like to compare the numbers after the decimal as if they're whole numbers. So first things first is you always want to make sure that it's the same number of digits behind the decimal. So we have 2 digits, 1 digit, 3 and 3. So we want to make the first 2 equal to the last 2. So we're just going to add zeros as placeholders because it doesn't change the value of it. All right, so now when we compare them, it's like saying 420, 600, 375, and 376. All right, we know the biggest is gonna be 600. So we're gonna put it back in its original form. So we'll mark them first. All right, so now this is the biggest. All right, the next one will be the 420, the 376, and the 375. All right, and then we just put them, now we put them back into their original form. All right, so our first value, we got 600, which is just the square root of 36. And you see how I stacked the work so I can keep track of what changes were made. This is how you should be doing it so that you can see how the transitions were made. So it's easier to understand what the answer is. All right, 42%, 0.376, and then 3/8, which would give us 8. All right, number 9 says arrange the values in ascending order. All right, so we have -1/4, the square root of 9, -2, and 160%. All right, so ascending means least to greatest. So we do the same thing, convert everything to decimals or percentages if you would like. And then we compare. All right, so -1/4 would be -0.25. All right, the square root of 9 would be 3. -2, we would just leave as. And then 160% will give us 1.60. All right, so our smaller values, so because we're dealing with negatives and positives, so we have 2 negative values. Negatives are always smaller than positives, always, always, always. So we have -0.25 and we have -2. So remember, the further away that a value is from 0, on the negative side, the smaller it is. So of course, -2 would be further away than 0.25. So this will be our smallest value, which means -0.25 would be our second smallest. And then now we're looking at 3 and 1.60. So we know this would be third and this would be fourth. All right, and then we go back and rewrite in our original forms. So we have -2, we have -0.4, 160%, and then the square root of 9, which would be B. All right, number 10. This is an example of converting between systems. So we have 2 1/4 yards is equal to inches. So you see how here I didn't give you guys a conversion factor, because normally it'll be a conversion factor here, because this is what's considered a common conversion. So this is something that has to be memorized. And if you guys have that cheat sheet that I gave you guys, I uploaded it into the group. It has all the conversions that you guys need to memorize. All right. And then the actual conversion is 1 yard is equal to 36 inches. All right, so anytime we do conversions, you always set it up the same exact way. So we always want to write out whatever value we start with first. And then remember, because we're doing a conversion, it's two ratios that we're multiplying times each other. All right, so because we have an improper fraction here, we want to convert to a decimal because it just makes it easier for us to do the math. So that subscale coming back in again. That would be 2.25. All right, so 2.25 yards. All right, so because we're doing a conversion, the units are very important because this is going to dictate how the units are set up on the opposite side. So because I'm going from yards to inches, I want to make sure that these yards cancel out. So in order for me to be able to do that, I have to put the yards for our conversion factor diagonal from it so they can cancel out. So I know that if yards are here, then inches will be at the top. And this is the most important part. This is where people tend to make the most mistakes. So you want to make sure that you don't make the actual mistake. And then from here, we fill in our values, add a 1 as a placeholder, and then you're just going to multiply straight across. So we're going to say 2.25 times 36, and then 1 times 1. Oh, and let me backtrack. So, and don't forget that because these yards are diagonal from each other, they ended up canceling out, which leaves us with the inches, which is what you want to do because that's what we're converting to. Say 2.25 times 36, which is 81. And then 1 times 1 is 1. 81 divided by 1 is 81. All right, so the answer is A. All right, so we made it through the first page. So what do you guys think? What do you guys think about this so far? You have any questions?
So far, I'm good. I just made the one mistake where I didn't round, and then those darn descending, ascending values.
Are you having an issue with like comparing them once you change them all to decimals? Like, what's the issue?
No, it's the I just have to remember that the negative number, the farther it is away from 0.
Oh, the smaller it is. Yeah, before you get to y'all probably really won't even see negative numbers. I doubt it. I mean, but you should be prepared just in case, but I
Yeah.
All right.
But other than that, I feel pretty good about it.
Okay, that's good. That's a good sign because that means that all this stuff comes from cluster 1. So that's good because then that means that cluster 1, you got it pretty down pat. So that's really good. All right, let's move on to this page. All right, so this particular question right here, this is an example of converting within a system. So anytime we do a conversion that is within a system, and we know this because we're going from meters to millimeters, this is when we use our acronym King Henry died by drinking chocolate milk. So this is just a matter of decimal movement from left to right. So I know meters is my base, and we know that this is a base because it doesn't have the actual prefix. So if we write out, we have our King Henry died by drinking chocolate milk. So I know that I'm starting here at my base, and then I want to end here at milli. So we never count where we start, we always count where we end. So I'm gonna go 1, 2, 3 places to the right. So that means that my decimal has to be moved 3 places to the right. So we're gonna go once, twice, 3 times. So that's gonna leave us with 86, which would be D. All right, number 12, 6.89 miles is equal to how many kilometers? So here they give us the conversion factor. So we just go through the question the same way as we did our previous one. So we set up our ratios. We always write where we start. So we have 6.89 miles. So because I have miles up top here, that means I need miles diagonal so they can cancel out. And then we have kilometers. All right, and then from there, you fill in the conversion factor, which is here. So we have 1.609 and 1 mile. And then we know we set it up correctly because the miles will end up canceling each other out. All right, add a 1 as a placeholder, and then you multiply straight across. So that will give us, this is too light, I can't see. 6.89 times 1.609 up top, and then 1 times 1 at the bottom. And that will give us some numbers.
11.86.
11.86, thank you. Wait, 11.086?
086.
There we go.
01.
Then 1 times 1 is 1. So we just would have 11.086. All right, and of course I didn't specify to round, but here you end up rounding to the nearest 100, which would give us B. Number 13 says the ratio of men to women at Brandon's gym is 1:4. If the local gym has an equivalent ratio, identify a possible ratio from the selection below. So remember, in the book, I give you guys where you set up the cross multiplication and you cross multiply. But when we actually went through the section, I showed you guys the shortcut that makes it easier. So it's not so much math. So in this instance, what you do is you change your ratios to fractions, and then you convert them to decimals to see if they match. So if I have 1:4, that's like saying 1/4. If I do 1 divided by 4, that gives me 0.25. So I need to figure out which one of these is going to give me 0.25. All right, so I can say 4 to 7 is the same thing as 4/7. 6 to 24 is the same thing as 6/24, so on and so forth. All right, and then we're going to convert everything to decimals. And you could do it either way. If you like the way I taught it in the book, that's cool. If you prefer the shortcut, that's cool as well. All right, so 4 divided by 7 gives me 0.5 something. 0.571. 6 divided by 24 gives me 0.25. 24 divided by 6 gives me 4, and then 7 divided by 4 gives me 1.75. All right, so we know that the answer is B, because they're both equivalent to 0.25. Number 14 A bag includes 6 blue marbles, 4 red marbles, 7 yellow marbles, and 5 green marbles. What is the ratio of blue and red marbles to the total number of marbles in the bag? So this is an example of solving real world problems involving ratios. So remember, when we're dealing with ratios, our keyword is 2. 2 is going to let us know where our colon goes, or fraction bar, whatever comes before that is our first value, or whatever comes after that is our second value. So it says the ratio of blue and red marbles. So and we know means to add, and then to the total means we add them all together. All right, so I had 6 blue and 4 red, and then all together we're saying 6 plus 4 plus 7 plus 5. All right, so we know 6 and 4 is 10, and 6, 4, 7, and 5 is 22. All right, so we can rewrite that as a fraction. And then we always need to reduce it down. So you always treat ratios like fractions. You want to reduce it to its lowest terms. So we can reduce both of these by 2 because they're even. Gives me 5/11, which is B. Number 15 says, the ratio of boys to girls in the school choir is 1 to 3. If there is a total of 21 girls in the choir, how many boys are there? So this is an example of finding a missing value given a ratio. So I know that we're looking at boys to girls, which is 1 to 3, which means for every 1 boy, there are 3 girls. All right, so we set these up. Ratios are like proportions, they equal quantities. All right, you always want to write your units first so that you can make sure you're not mixing up your values. So we'll say boys up top, girls on the bottom. Make sure they match on both sides. All right, so say 1 boy for 3 girls, and then they give us 21 girls. All right, and then from here, you just do math. So you always cross multiply wherever you have 2 values. We say 1 times 21 is equal to 21. And then we always divide by the value that's left over, which is the 3. Say 21 divided by 3, which gives us 7. All right, the answer is C. Number 16 says there are 60 football players, 35 basketball players, and 28 baseball players visiting the local college for a sports camp. What is the ratio of basketball players to football players? So our giveaway is the word 2. 2 lets us know where our colon is going to be. All right, so we have basketball and then we have football. So we have 35 basketball players and we have 60 football players. All right, and then remember that ratios always have to be reduced down just like fractions. All right, so if I have 35 to 60, it's like saying 35 over 60. We can reduce both of those by 5. That would give us 7/12, which would be 7 to 12. Number 17. All right, now we're moving into proportions. It says, Alicia can bake 10 cakes in 1 day. At this rate, how many cakes can she bake in 2 weeks? So when we're dealing with proportions, we always want to know, what are we actually talking about? So we're talking about cakes, and then we're talking about times. They give us day, and then they give us weeks. So that means we have to do some type of conversion in here. So I know that 1 week is 7 days. So if I'm given 2 weeks, I know that I can rewrite that as 14 days. All right, and then now we're ready to do some math. All right. I'm gonna say C for cake and D for days. All right, 10 cakes in 1 day. And then 14 days. All right, cross multiply where you have 2 values. So 10 times 14 is 140. And then we always divide by the value that's left over. So 140 divided by 1, which is just 140. Which would be D. Everybody doing okay so far? Do we have any questions?
No, I'm all right. I'm feeling proud of myself over here.
See, making progress. Always good to hear. All right, number 18, it says, Alexis can type 3 1/4 pages in 2 hours. At this rate, how many pages can she type in 6 hours? So anytime, this is also an example of proportion. We're given 3 values, looking for a 4th. We're dealing with pages and hours. All right, now because we have this mixed number here, it's always easier to change it to a decimal to make the math a little easier. All right. So from here, we just set up our ratios. All right, we did P for pages and H for hours. All right, so 3.25 in 2 hours, 6 hours. All right, so cross multiply wherever we have 2 values. So we're saying 3.25 times 6, which is something 19.5. And then we divide by the value that's left over. So we divide that by 2, and that gives us something 9.75. Which would be B. All right, number 19 says, if Stephanie's nephew can eat 1.5 pizzas in 2 hours, how many can eat in 5 hours? So same idea, we're talking about pizzas and we're talking about hours. All right, and because we have a mixed number here, we're gonna change it to decimals, it's 1.5. All right, and we're gonna go ahead and set up our proportions. P for pizza, and H for hours. 1.5 and 2, 5. Cross multiply where we have 2 values. So 1.5 times 5, which is something 7.5. And then we divide by the value that's left over, which gives us 3.75, which is C. On number 20, says Ashley purchased 8 pairs of shoes in 2 weeks. If she continues to shop at this rate, how many shoes will she purchase in 3 months? So what are we talking about? We're talking about shoes and we're dealing with time. So they give us 2 weeks and then they give us 3 months. All right, so we want to change months to weeks. So we know there are 4 weeks in a month, so that would be equal to 12 weeks. All right, so we set up our ratios. We have S for shoes and W for weeks. And we have 8 and 2, and then we have 12. Cross multiply where we have 2 values. So we're saying 12 times 8, which is 96. And divide by the value that's left over. 96 divided by 2 is 48. The answer is D. One second. Number 21 says Ashley's gross pay last year was $46,986. If she paid 15% in taxes, how much was her take-home pay? So take-home means after we do all of our deductions. So we need to see what's left over. So if we want to figure out how much 15% in taxes was, all we're going to do is multiply this times the 46,986. But you can never multiply a number times a percentage. It always has to be converted to a decimal first. So that's going to be 0.15. So we would do the 46,986 times 0.15, which will give us some value. $7,047.90. All right, so this will tell us how much she paid in taxes. But the question is asking what was her take-home pay. So what we have to do is we have to deduct this from her gross. And you guys should be somewhat familiar with this because this is how it goes when you work and you get paid and money that they take out. All right, so it's saying the 46986 minus the 704.7.9, which is going to give us roughly 39,938. All right. So we just finished second page. We're almost done. We got 15 questions left. How'd you guys do on this page right here?
I made a dumb mistake, but overall I've done so okay so far.
Okay.
Take home. Yeah.
All right. A little over halfway there. So how you guys feeling about the content so far? What are you guys thinking?
Well, I feel okay about it. I just didn't pay attention to the wording, specifically what the question was asking.
But you understand why you made the mistake?
Mm-hmm. Mm-hmm.
Okay, but that's as long as you understand the why, then it's easier for you to not make the mistake again. So that's really like the most important part.
Mm-hmm.
Okay, so at this point in your studying, how do you guys feel like about the content?
Well, I mean, I feel that it's broken down to where I can understand it, and especially with practice, I keep doing it. It comes even easier. The simplest math, I just did the simplest math. I was not a math person now. I truly, I'm understanding it.
Well, that's good. I'm excited for you guys.
Yeah, it's a little further along in it, but that gave me a little bit of trouble. But I'm waiting till you get to those.
Okay. All right, let's see. All right, number 22. Employees at World receive a discount of 20% off every purchase. If one employee spends $75 and another employee spends $100, how much money will they receive off their purchases together? All right, so first things first, we know we're dealing with discounts, and then the discount is a value of 20%. All right, so you have two people who made purchases, one for 75 and one for 100. The question is asking, how much will they receive off their purchase? So they don't want to know what they're paying. They want to know how much of a discount are they receiving. And they're saying together. So together means we need to add them together. First and foremost. All right, so we're saying 75 plus 100 equals $175. So that's what they spent all together. They got a discount of 20% off. So we know anytime we're trying to figure out a percentage off something, we're going to multiply. You can never multiply times the actual percent. You have to convert it to a decimal. All right, so 0.20. All right, we're going to multiply that. And that's going to give us some number. $35 off. All right, number 23 says, Aaliyah always tips the waitress 15%. If her total bill came to $23.49, how much of a tip will she leave? So we know what she wants to leave percentage-wise, and then we know what the total is, $23.49. So we want to figure out how much the tip is. We need to figure that out based on what she spent. We're going to multiply times the percentage. So just like the previous question, we want to change this to a decimal. So that gives us 0.15. And then we're going to multiply that times this. That's 3.52, which would give us C. Number 24 says, Gina purchased a pair of denim shorts that were on sale for $25. If the original price was $40, what was the percent decrease in price? So it says percent decrease. So anytime we do percent change, we always do our same setup. We're going to subtract the values up top. We'll create a fraction, subtract the values, and divide by the original value. So I know that we have 40 and 25. All right, now we need to decide what was the original value. So if we go back and look at the question, it says Gina purchased a pair of denim shorts that were on sale for $25 if the original price was 40. So original is the starting point. So we're going to divide by the 40. All right, 40 minus 25 is 15. Then we do 15 divided by 40 because we need to convert our fraction to a percent. So if we do 15 divided by 40, that gives us 0.375. And then we need to convert that to a percent. So we'll decimal 2 places to the left. That gives us 37.5, which is Number 25, it says, as students study more hours, their test scores increase. Identify the dependent variable. All right, so dependent is what's being measured. That's what's actually changing based on something else. So first thing we needed to figure out is what two things are we talking about? So it says, as students study more hours, their test scores increase. So we're talking about hours and we're talking about test scores. So we have to figure out which one is dependent upon the other. So when students study more, the test scores go up. So this is impacting the test score, which means the test score is the dependent. So the only thing you have to ask yourself is what's being impacted? What's dependent on the other one? Number 26 says, what type of relationship does this graph illustrate? So this is a scattered plot. All right, so it's either going to be a positive, negative, or no correlation. So positive would mean that it's primarily rising from left to right. Negative would mean it's primarily falling from left to right. And then no correlation means there's no particular pattern. So if we scan this from left to right, there's no particular pattern, meaning that if I were to draw a line through here, like this will be positive correlation, most of the dots don't group around the line, they're kind of just scattered about. So in this case, it would be no correlation. It's no relationships, no obvious direction of most of the dots. 27 says, as athletes age, their bones weaken. Identify the independent variable. So independent is what's influencing the change. All right, what two things are we talking about? Age and bones. So a giveaway is time is always an independent variable. Time is always independent. And that's on the notes page of this section, which talks about the relationship between two variables. We have a graph. It says, if there are 110 football players, how many of them are seniors? So we take a look at our graph. Our graph is broken down into percentages. So first things first, we need to locate the seniors, which are here, and they're going to make up 20% of the football players. But we want to know, based on our total, which is 110, how many actual seniors are there? Anytime they give you a graph that is made up of percentages, and we're trying to figure out an actual whole number based on data that they give us, you always multiply. Always, always, always. So first things first, we know that we can't multiply by a percent. It has to be changed to a decimal. So we know this is going to be 0.20. I'm going to say 110 times 0.20, which gives us 22. All right. So do we have any questions from this page right here?
I do. So for number 27, the age is the dependent variable.
27 is asking for independent.
I mean, the independent, it will be the age?
Yeah, because age is influencing the bone strength.
Okay.
And then if you think about it like this, independent is something that you can't be changed. So nothing can influence your age. You're going to age. It's a process that people can't stop.
Okay, nothing can influence. Okay.
Mm-hmm. Got it.
Okay. Got it. Thank you.
Mm-hmm. All right, almost done. We only have 8 more questions to go. All right, we're looking at number 29. It says, which graph would best illustrate a normal distribution? All right, so the key word here is distribution. Distributions can only be highlighted in one type of graph, which is a histogram. That's just something you just have to memorize. Number 30 says, what percentage of student enrollment do math and reading account for? So if we look at our chart, it says exceptional studies tutoring student enrollment by subject area May 2013. So we have 58, 43, 29, 45, and 15. So the question is asking for a percentage. So anytime they're looking for a percentage and they're only giving us whole numbers, you should know that first things first is you have to create some type of fraction. And at the bottom of that fraction is going to be the total of whatever we're dealing with. And then the top is always whatever the question is asking for. So in this case, we're looking for math and reading. All right, and then from there, we'll be able to convert to a percentage. So total, when we add all of these values up together, we get 58 plus 43 plus 29 plus 45 plus 15. That gives us 190. And then math and reading. So and means we add. So we're saying 58 plus 43, which is 101. All right, and then we're going to convert this to a percentage. So first things first, we're going to convert to a decimal. So we say 101 divided by 190, which gives us 0.531. And then we want to convert that to a percent. So we're going 2 places to the right, just 53.1%, which would be C. All right. Number 31 says, which graph shape has a mean that is greater than the median? So this is just something you have to memorize. And then in this instance, it would be positive. All right, number 32, it says, calculate the mean of the given data set. So we have 24, we have 10, we have 35, we have 39, and then we have 19. So mean means that we have to add all these together and divide by the number of values. So we know we have 1, 2, 3, 4, 5 values all together. So we're going to add them up and then divide by 5. All right, so we're going to say 24 plus 10 plus 35 plus 39 plus 19 divided by 5. All right. And if we go ahead and do the math, 1 minute. So 4 plus 10 plus 127. And then we did 127 divided by 5. 25.4. Which is B. 33. 33 says to calculate the median of the data set. We have 24, 10, 35, 30, 39, 19. So same exact thing. So anytime you guys are finding the median, that's going to be the value in the middle. The first thing you always have to do is you have to put these in order from least to greatest before you can decide what falls in the middle. All right, so I know if I do that, I'm going to have 10, 19, 24, 35, and 39. All right, and because I have an odd data set, there's only going to be one value in the center. And I like to just cross them off from the ends and come to the middle. So I know I did 1 and 1, 2 and 2, which left me with 24. All right. All right, number 34 says a square has an area of 225 inches square. What is the measure of one side? So anytime we're dealing with geometry, you guys want to always make sure you understand the properties of the shapes that we're dealing with. So because we're dealing with a square, we know that a square is equal on all sides. So if we draw it out, we know that all the sides are equal. And in this instance, they're telling us that the area is 225. And we want to figure out what's the measure of one side, which would be the same all the way around. All right, so because we're dealing with a square, I know if I want to find the area of a square, I do side times side, right? So if I just say side times side, that's the same thing as saying side squared, which would be the area. So if I say side squared equals 225, if I want to solve for that side, I would just take the square root of both sides. And the S will be equal to 15, because 15 times 15 gives us 225. Number 35 says, a circle has a diameter of 10 centimeters. What is its area in terms of pi? All right, so in terms of pi means that instead of substituting in the 3.14 for pi, we just leave it as is. So we know the area of a circle is pi r squared, where r is the radius. Now here they give us the diameter. So when you're dealing with circles, you want to make sure you understand the relationship between the diameter and the radius. And then we know that the radius is half of the diameter. So if the diameter is 10, that means the radius has to be 5. All right. And then we just plug in what we have. So we keep pi there. And then instead of the radius, we substitute in 5. And then we do the math. So we say 5 squared is 25. And if we do pi times 25, it's just 25 pi. Just switch it around. And that's it. Which would be B. All right, and then our last one. Solve for the missing dimensions of the figure below. So just looking at it, we can assume that this is a rectangle. The value here of the center is going to be our area, and we know this because it's an inches squared, so that lets us know that's the area. This is our width, so we're looking for the length. All right, so I know that the area of a rectangle is length times width. So they gave us the area, which was 218, and they gave us the width, which is 24. Just gonna plug in what we have. All right, 218, and then L times 24. All right, and then we could just say that's 24L and multiply. And then if we want to solve for L, we divide both sides by 24. And what does that give us? 9.08. which is C. All right, so that is your clusters 1 through 3 review. So midway through the book, this just gives you an idea of where you are. So if you can score at least an 80% on here, then you're in a good space. That means you're like retaining the content. And I would suggest moving forward. If you get anything below 80%, I would say like 75, 80, but really shoot for at least 80. Go back and review the topics that you need help with. So you guys have any questions from this page?
No, actually, I'm good. I needed those last 2 worked out, and I see what you did. So I just need to go back and practice that some more.
Okay.
Overall, I would give myself like a 85, 90%.
Oh, you did great. See, and you're always saying how bad your nerves are. So do you feel like you're progressing? Like, do you see where you're making improvements with the math?
Oh yeah, I see big improvement. And some of it was just not totally not understanding it, but getting my confidence up about it.
Yeah, and I'll
see
tell you guys that math is a lot of confidence, has a lot to do with confidence. Well, I'm excited that I was able to go through all of these questions with you guys tonight, and I'm glad that you guys are able to see the progression, because that's my goal. Is I want to make sure that you're seeing the progression and you're seeing that it's actually happening. So that is very exciting. So I'm so glad that we were able to get this done tonight. And we will meet again on Sunday. And this Sunday we will start cluster 4, which is fractions. And fractions is very straightforward the way that I teach it. So we'll get through that pretty quick. So you guys need anything else from me before we get out of here?
No, I'm good for tonight. Are we meeting again on Sunday?
Yep, we'll do Sunday at 8 and start cluster 4. Okay.
Okay.
All right, sounds good. You guys have a good night. Thank you guys so much for participating.